Hello everyone, we're here to introduce our water safety demonstration tank, also known as a water safety flume, which we've created in partnership with JBA Trust.
The inserts we've created are designed to represent specific water safety hazards, some man-made and some natural, which can be found throughout the country.
We will now pass you over to Alex and Bridget from JBA Trust, who will demonstrate each of the hazards.
This is our water safety flume. We can use it to show how a range of different river features, so natural and man-made, things like waterfalls, weirs, culverts and stepping stones, can affect the flow of water and some of the associated safety risks with that change in flow of water. We use it with schools and communities to raise awareness of water safety.
So let us introduce you to the flume. We've got the main river channel here and it's made out of perspex. We've got water flowing through that's being pumped around by some pumps in a water tank at the end of the flume, and it's a recirculating system. The water in here, we've added a bit of non-toxic blue dye. It just helps it to show up and to be a bit more visible. Here's our model waterfall. So we've got water cascading over the waterfall into a plunge pool. We've got our model people here that we're going to put into the water to see what happens to them. So here we go. First person falls over the waterfall into the plunge pool. You can see that it's getting recirculated around, not escaping. There's the other one. So the water down here is highly aerated, so it's reducing buoyancy, so it's a lot harder to float. Plunge pools, waterfalls might be really deep. The riverbed next to the waterfall might shelve steeply. And there can be all sorts of hidden dangers, for example, debris like wood and all sorts of other things. And hidden rocks. Rocks move with the forces of the water too.
This section of the flume represents the STRID. So the STRID is one of the most deadly sections of water in the country. It's where a wide river is constricted into a very narrow channel, constricting the flow into a very deep, very aerated section of water. We put our model person in and we can see what happens. So there they go, they've sped up into the flow of the water. There's also lots of hidden dangers in the STRID, whirlpools, undercut sections, and it's very difficult to get out of once you're in. Nobody actually knows how deep the STRID is.
Here is our model of stepping stones. So they're a man-made feature, and there are all sorts of hazards that we might not think about when we're crossing stepping stones. So there might be missing stones, they might be unstable, they might have been washed away in floods or high river levels. You'll be able to see here that there's quite a slow flow above the stepping stones, but as the water passes through, it gets quicker and quicker. So if someone was to fall in, then they would get washed away quite quickly. As river levels rise, there's a risk of water pushing off anyone who's on the stepping stones, and also the stepping stones might be very slippy. We're going to simulate more water coming down a river. I'm going to open the throttle a bit on our flume and let's see what happens. So you'll be able to see there's more volume of water coming over, and we're just going to knock this person off for an example to see how fast this person flows in the water.
Our next insert in the flume is a weir, in this case a broad-crested weir. So weirs have been traditionally put into rivers to raise the water level upstream, perhaps for abstraction or for industrial use. There are a lot still in our rivers today in varying states of condition. You can see that upstream of the weir, the flow is quite slow, and then all of a sudden it speeds up very quickly. We can show how the broad-crested weir affects the flow of water in the river by using this canoe to demonstrate. So if we put that going down the river, just heading over the weir, as it goes over the weir, it gets caught in the backwash, and the towback pulls it back into the foot of the weir, and it gets recirculated. Weirs can also present a massive risk to people swimming in the river. You might get in upstream thinking it's a relatively slow and steady river, get swept over and find yourself suddenly in deep water getting towed back into the weir. And weirs can be in various states of repair, so they're not always in great condition. There can be sharp edges, missing bits of rock, and it's also kind of dangerous for people to come in and attempt to rescue from a weir.
As we've already mentioned, there are lots of different designs of weirs. Here we've got a collection of 3 different weirs. They're vertical weirs, and they show examples of a closed side weir, so there's no way of getting out from either side. We're going to add a person here into this weir, and we're going to add a person down here as well. And what we'll notice is that they keep getting recirculated around and around, with actually no easy way of getting out. Even the strongest swimmers would find it difficult to get out here. And there's reduced buoyancy here because there's lots of aerated water, so it's not possible to float so easily. There are hidden dangers in rivers, for example, shopping trolleys, branches. So what we've got here, we've got some shopping trolleys in our river Flume. We're going to add a person and see what happens. You can see here that the person has actually got stuck inside the shopping trolley underwater. Now is getting popped out, but there's not really an easy way to escape.
A feature that you might see on a weir is a fish path. So it's a series of steps up, and this enables a fish to navigate its way upstream and get past this barrier. So they might look very interesting, but they're actually quite dangerous places for people to explore. Water can be quite aerated, there might be submerged or hidden obstacles underneath, so it's best to avoid those if you can.
Here we have our model of a culvert. So culverts are used to transport watercourses underneath. It might be buildings, it might be under existing infrastructure like roads or railways. So they can be classed as hazardous environments, so quite dangerous. So debris can get washed down and get stuck in there. It can be dark underneath, there can be bends. There's just a lot of unknowns about it. So what we're going to show you is we've got a duck, and we'll show you how the water flows, how it speeds up as it goes through the culvert. So we'll put it upstream, it's going quite slowly, gets to the culvert, zooms in, and then at the outflow it goes very fast. We're also going to introduce some debris now and to see what happens there when we add a duck in. So you'll see that the duck is actually pinned against the shopping trolley in here. Because of the pressure behind the duck, of the water coming in, there's actually very little way of getting out of that situation.
So over the years, various features have been introduced to try and prevent people and debris getting into the culvert in the first place. So you might see this on culverts. This is a screen or a strainer. We're just going to put this on to show you the impact of this on potential things going in the culvert. So if we use our duck as an example, the duck is actually very buoyant. But you can see that as soon as it hits the culvert, it gets pressed up against the screen. And if we press it down further, you can see that it's actually completely pinned against that screen now. And this is a very dangerous situation to be in. And it's very difficult to rescue people out of that situation. It also has an impact on flood risk. So if we use this example as debris washing down the river, and if we look at the water level, you can see that it's starting to go up here. So any blockage on these screens is difficult to remove and results in potentially increased flood risk upstream of the culvert. So there have been some design improvements over the years to culverts which make them safer. This is a step culvert, which is a lot easier to maintain and a lot safer for anything getting stuck onto it. So if we put that in, and now if we use our duck as an example, you can see that if we try and pin the duck onto the culvert, it's actually still very buoyant. It's not going to get pinned, it's easier to escape off either side. And it doesn't affect the water level upstream, so it's a much lower flood risk. So you can see that our debris gets stuck there and there isn't any increase in the water level upstream.
is our model of a bridge. So this is a bridge pier. So bridge piers are built either straight or at an angle in a river. And the bridges might carry transport and might carry pedestrians, for example. If we have bridge piers in a river, they act as an obstruction. So we're going to put our duck in to see how the water flows next to a bridge. So it's going fairly slowly, and then it speeds up as it flows past because the water's being pushed around the sides. I'm going to add a piece of our model debris in here. We'll be able to see that the water is actually pushing the debris up against the bridge pier. It might be debris or it might be people. There's also an eddy that is created, often created, downstream of a bridge pier.
Thank you for joining us to learn more about rivers and water safety.
For more information, please follow these links.